Good morning 5B. Today is 12th of June, Friday. Right, today we'll be going through the last part of using electricity topical worksheet, right? Question 13 to 15. So same thing, make sure you do the corrections and I'll see you back in school next week. Alright, so let's start with question 13. Question 13 is about electrical circuit. You have two switches, S1 and S2. You have three switches, S1, S2, S3. You have two bulbs, L1 and L2. So what you're supposed to do is that you're supposed to infer when, for example, these three switches they are open, they are closed, they are closed. What happens to lamp number one and so on and so forth. Okay, so basically based on the variables that they have stated, check out or work it out whether the bulb lights up or not. Okay, so let's start with the first one. Okay, let's write down what we know. Okay, so for the first scenario, S1 is open. Okay, leave it open. S2 is closed, S3 is closed. So I'll just close it. And then I use my highlighter. Same thing, go and trace. Okay, so if S1 is open, S2 and S3 are closed, you realize that there is an open circuit. Okay, you realize there's an open circuit, and once there's an open circuit, you know electric current cannot flow through. And if electric current cannot flow through, this will not light up, this will not light up straight away. So straightforward, this one is no. Alright, so let's go for the second one. Now we erase everything away, and then now S1 is closed, so I'll close S1. S2 is open, so I'll leave it open. S3 I don't know, so I'll put a question mark here. But I know L1 and L2 lights up, so lights up, lights up. So again, use your highlighter. Okay, the fact that L1 lights up and L2 lights up means there must be a closed circuit. So let's start from here, go to here. Okay, we know for sure that S2 is closed. We know for sure that S2 is open. So we know that electric current cannot flow downwards. It will just go over here. Okay, we don't know about S3, but since we know that L2 lights up, means that there must be a closed circuit like this, all the way up and back again. So we know that S3 must be closed as well in order for there to be a closed circuit. So S3 is closed, so it is closed. Right, let's go to the next one. Okay, let's erase everything away first. Okay, so now let's go to the next one. Okay, the next one, we don't know about S1, so we put a question mark at S1. We know S2 is open, leave it open. We know S3 is closed. So S3 is closed, and now we know that both do not light up. So didn't light up, and this also didn't light up. Okay, so use a highlighter. We don't know about S1, okay, but we know we can backtrack from the other side. So let's go from the other side. Okay, we know S2 is open, so it won't go up. You realize you can go through this bulb over here and over here. Okay, but the fact that we know S1 did not light up, because if this was closed, there will be a closed circuit, S1 will light up. But the fact that oh, I realized that I made a mistake. Okay, you realize that, okay, let's restart over this. Okay, let's start again. Sorry about that. Okay, so let's start again. Scenario 3, S1 I don't know, so I still put a question mark there. S1 I don't know. S2 is open, leave it open. S3 is closed. Okay, L2 doesn't work, L1 doesn't work. Okay, so if both doesn't work means there must be a open circuit. Okay, so if I trace like that, okay, the fact that it's closed means, hey, electric current should flow through. Okay, but I realize that if S1 is closed, that means it will be a closed circuit, and then both will light up. But the fact that both did not light up means this must be a open circuit. So this one is a open circuit. Okay, so once again, the fact that this is open and this is open, which is already given. If this is open, there will be an open circuit. That's why L1 and L2 did not light up. Okay, if it's closed, L1 and L2 can light up. Okay, so let's go for the last one. Okay, we know that S1 is closed, so I'll close S1. I know S2 and S3 are open, and I know L1 did not light up. So what about L2? Okay, so I put a question mark over here. Okay, so same thing, trace the electric current flow. Yeah, it should be able to flow through here. I know S2 is open, so it can't flow through. You realize that it can't flow through anything. Okay, it can't flow through anything because there is a open circuit. Okay, so in this case, both will be not lighted up, so both will be no. Alright, so all you need to do is really to um, look at the diagram one by one and then trace the flow of electric current. If there's a closed circuit, it will light up. If it's not a closed circuit, it will not light up. It's as simple as that. Okay, so the next part is you want to make use of only 4 wires. You want to connect the 3 batteries and the bulb together to form a circuit that the bulb will light up the brightest. So now you're going to think about it. How do you make the bulb the brightest? Okay, what have we learned? We got 3 batteries. Do we want to arrange them in series or parallel? Okay, actually in your syllabus you only learn that you can only arrange batteries in series. Okay, so the main thing is to arrange them in series, the batteries, okay, because there's only one bulb. Okay, you can't arrange the bulb in series or parallel. Okay, so what you need to do is to arrange them in series. So same thing, draw straight lines using ruler. So we start from this battery. Remember, you need to connect them in series, means the plus must go to the positive must go to the negative. Okay, let's draw this. Okay, see, this is one wire, but of course I bend it. Okay, remember, positive must go to the negative. Okay, so that this is one wire, although it's like many lines, but this is just one wire. We bend it, and then this is the second wire. Okay, make sure they touch each other. Later I will adjust. Okay, make sure the wires touch all the parts. And then, yeah, let's finish up the second wire. Okay, remember it's always the positive to the negative, positive to the negative. This is the second wire. Now we go for the third wire that I will connect to the metal casing. And then the last wire from the metal tip to the negative terminal of the battery. Yeah, something like that. So you have one wire, two wire, three wires, and four wires, and they are all connected in. The batteries are all connected in series. Okay, so this is question 13, quite simple. Let's go on to question 14. Okay, question 14 is you have four circuits over here. Let's identify how they are arranged. This one is both the batteries and the bulbs are arranged in series. Okay, while this one also, this one there's only one battery, but the bulbs are arranged in series. This one, the bulbs are arranged in series. Bulbs in series. Oh, sorry, bulbs in parallel. And the next one, this is batteries. This is also series, but batteries in series. So you have three series circuit and one bulbs in parallel circuit. Alright, so we are going to arrange them in order of brightness from the dimmest to the brightest. Let's go for the brightest first. Okay, when you're considering the brightest, right, first consider the number of batteries that each have. Okay, so here I realize that there are, for example, here there are three batteries, here there are three batteries. This only one, this only two. So we look at the three batteries one first. Okay, this one is three batteries, two bulbs in series. These three batteries, one bulb in series. Definitely three batteries, definitely the one with less bulb will be brighter, because the more bulbs you add in series, the less bright it becomes. So for the brightest, it must be D. Okay, now let's look at the dimmest. We always go to the extreme end first. Okay, so you have three batteries, you have two batteries, and then you have one battery. And when there's one battery, you have two bulbs connected in series. Again, you do remember that the more bulbs you use in series, the more bulbs there are connected in series, the less bright it becomes. So C is the dimmest. Alright, so now we are left with A and B. Okay, so A, you realize is 3 batteries with 2 bulbs connected in series, while B is 2 batteries but they are connected in parallel. So in a sense, it we learned before, if you connect bulbs in parallel, the brightness doesn't change no matter how many bulbs you connect in parallel. So these two are the same in a sense, but there is 2 batteries here. Okay, so this is in a sense, okay, so each bulb will have the brightness of 2 batteries. Okay, okay, because we know that when you connect bulbs in parallel, the brightness doesn't change, the brightness remains the same. So this bulb will have the brightness of 2 batteries. However, um when you are connecting bulbs in series, the more bulbs you add, the dimmer it gets. So for A, okay, later let's write it over here. Okay, let's type first. So here you only have the brightness of uh, 1.5 batteries in a sense. Okay, because you know that the more batteries and the more bulbs you add in parallel, the less bright it becomes. Okay, so in that case, we know that B must be brighter and then A must be less bright. Okay, because one is the brightness of 1.5, this is brightness of 2 batteries. Okay, so it's CABD. Okay, again we know that circuit B is connected in parallel, or the bulbs are connected in parallel. So what's the advantage of circuits of of connecting bulbs in parallel? So very simple, you know that there are actually many advantages, and one of them is that when one bulb fuses, the other bulb is still able to light up. Alright, so when you have a parallel circuit, this is the good thing about parallel circuit, because when one fuse, either one, the other one can still light up. Okay, because it's still a closed circuit. Okay? Or at least a closed circuit is still formed even if one bulb fuses. Okay, so let's go on to the last question. Alright, so I have 4 bulbs over here, and I have 4 bulbs over here. They are all working fine, and I have 4 different positions STUV where I can put a switch. Okay, I can put a switch here, 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 or here, it depends, but I just want to put one switch. However, there's a condition, because I want to put a switch that is able to just off one bulb while the other is still lighted up. So the switch can only control one bulb, not all the bulbs, not 2 bulbs, not 3 bulbs, but only one bulb. Okay, so where should I put the switch? Okay, so once you look at the analyze diagram properly, you realize that over here, I'm going to highlight over here, realize this part is connected, this bulb in particular is connected in parallel. Alright, so if once again, if you look at the diagram carefully, you realize that this bulb here and this position, actually this bulb here is connected in parallel compared to the rest of the bulbs. Okay, this is in parallel. So if you only want to control one bulb only and leaving the rest of the bulb lighted up, okay, you realize that you, it's only that if you put at position T, then you can control this bulb, because if you put at position U or V, um, if you open a switch, it will become an open circuit, because the electric current cannot flow through here. Electric current can flow through here, but then it gets stuck here, then it will be an open circuit. So S wise, even if you put it here, yes, the electric current can flow through the inner loop over here, if this is yeah, okay, but if you put a switch here, the problem is that when you put a switch here, when you open a switch, the electricity will not go through here. So actually effectively you are controlling 2 bulbs instead of 1 bulb. Remember, you just want to control 1 bulb, switch off 1 bulb. Okay, so you put at T, open the circuit, electric current cannot flow through here, but the rest is still a open circuit. So if I draw it in a diagram form, okay, let's draw in a diagram form. So let's say this is a switch. Let's draw like that, and then let's say it's open. Okay, now this is like an open switch. Okay, so you realize that if I have a switch at T and I open the switch, electric current can still flow through here, 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 here. It doesn't go down that parallel side. Okay, so effectively you're just controlling only one bulb. Okay, so let's put the claim down. Okay, so where should I install the switch? I should install it at T. And what's the evidence? Okay, because we can see that the bulb near T is connected in parallel. Okay. Okay, only the bulb near T or the bulb at T is arranged in parallel. The rest are arranged in series. Okay, and that's what you can see from the diagram. So what's the reason for choosing T? Okay, because you realize that when the switch at T is open, okay, the electric current doesn't flow through the bulb at T, but it can still flow through the rest of the bulb. Alright, okay, so basically we want to put the switch at T. Reason is because when the switch at T is open, the electric current, okay, let's put in the word current, does not flow through the bulb at T, but it can still flow through the rest of the bulbs because there's still a closed circuit connecting them, as what I shown just now. Okay, so with this, let's try to write them down in words in full. Right, so in full, I just write the same thing, slightly with a bit of changes. So you realize that, okay, let's put it properly like this. Okay, maybe put a background to be better. Right, okay, can. Okay, so what I wrote here is that the answer is T because the bulb at T is arranged in parallel. So when the switch at T is open, for example, electric current cannot flow through the bulb at T because the switch is open, but it can still flow through the rest of the bulbs because there's still a closed circuit connecting the rest. Okay, simple as that. Okay, so with that, we have finished this using electricity topical worksheet. Make sure that all questions are done. Make sure that all corrections are done. Uh, don't need to worry whether your answer is correct or not. It'll be best that you also have a copy of my answer on your worksheet so that you know how I construct the answer, especially the claim, evidence, and reasoning part. Alright, see you back in school on Monday.